Good morning, everyone. Today we're going to talk about lesson 11.4, which is geometric series. By now, hopefully, we've got a pretty solid background and we're feeling good about lessons 1 through 3, hopefully. So, lesson 4 shouldn't be a whole ton of new information. Now, there's only a couple of small things that would be more difficult with it. If you were still trying to count up everything without using the formulas, this one's gonna be really hard to do because geometric sequences get really big really fast, and then geometric series can create some really, really large numbers. So if you're trying to write out the sequence and then add them all up, which you can do, the numbers are just gonna get really big and it's gonna be very time consuming for you. But for the most part, geometric series is no more difficult than any of the other ones. So let's dive in. Just to reiterate the things that we've talked about so far, a sequence is a number pattern. Now, up until now, we've worked with only arithmetic and geometric sequences, which are number patterns that we add or we multiply between terms. We are, later in the chapter, going to talk about some number patterns that do not follow one of these two groupings. Okay? The next thing we talked about is a series, which is the sum of all numbers in a sequence. So if you take all the numbers in your sequence and add them together, that's a series. Sequence and series are arithmetic if we add between terms. Sequences and series are geometric when we multiply between terms. We're going to be working with only geometric series and sequence today. So things like 2, 4, 8, 16, 32, or things like 81, 27, 9, 3, 1. In this case, we're multiplying 2 each time. In this case, we're multiplying 1/3 each time. In both cases, our goal for the day is going to be to add up all the numbers in the series. Now again, we're talking about series that have a start point and an end point. When I come back tomorrow, we're going to start talking about series that go on infinitely. So if we could add every number in the whole number pattern together, what would we get? Okay? And so that's our goal for tomorrow, which is not much harder than what we're doing today. Maybe even easier mathematically, but conceptually it's a little harder. So let's dive right into today. The formula for our geometric series is S of n, which is the series of the numbers, so this is just our answer, equals A1 is our first term, R, which comes up twice in the formula, once on the top and once on the bottom, is our common ratio. So let's pause and talk about common ratio. Just a reminder from yesterday, the common ratio is the number that we are multiplying between terms in a geometric sequence. And then the last piece of our formula is n, which is the number of the term we're going to stop at. Hopefully by now we've kind of figured out the difference between n and an and sn, okay? But I'm just going to kind of try to separate that while I'm waiting for everybody to have an opportunity to copy some of this stuff down. So an is the actual last term. So if my 14th term in my sequence is 32, an is 32. The actual value of that term. N is 14 because it's the 14th term. Then Sn would be the sum of all of the first 14 terms. So term 1 plus term 2 plus term 3 plus term 4 up to term 14. So all of those components should be in place for you there. Okay? Up here, just as a reminder, I've listed our geometric sequence formula that we worked with yesterday. So just a reminder of those components. Again, an is our final term, a1 is our first term, r is our common ratio, or what we multiply by each time, and n is the number of terms we're going to. So whatever term an is, the n is connected to that. But they're not the same number, right? If the 14th term is 32, an is 32, n is 14. One other thing I'd like to point out about the geometric series formula versus all the other formulas. This is the only formula of the 4 formulas we've worked with that does not use n minus 1. The series and sequence and all the formulas used n minus 1. And this one only has an n up here, so be careful with that. Don't fall into the trap of trying to subtract 1 from your n value because all the rest did. All right, down below I have 2 examples. This first example is the most tricky type of problem that we're going to come across. And they're the type of problems that are missing information, but not only are they just missing information, but they're missing n. And n is going to be the most important piece of information to go find, because it's the most difficult to find from the sequence formula. Now I'm going to do a couple other examples from the homework later that are missing other information or not missing any information. But this particular problem poses us an extra issue because I don't have an n value. I do know a1 and an and r, but I don't know n. So I'm going to fill in my series formula. S sub n equals a1 is 729 to the 1 minus r is negative 1/3 to the nth power over 1 minus negative 1/3. Now you need to be careful with a couple of things on this one. First of all, my negative, 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 negative here are going to chop chop. But not on the top because the power is going to come first. And so the hesitation here, the thing that students will do a lot of times is they'll chop chop here and here right away. But we don't know what n is, so we don't know if it's actually going to square out that negative or not. So we need to be really, really careful using our order of operations on the top. The other thing that is occurring in this particular sequence is that we're ending up with a rotational positive negative value because of the negative r value. Every time we times by a negative, and we probably saw this in several examples yesterday, but every time we times by a negative, it takes positive, negative, positive, negative, positive, negative, because you're timesing by a new negative each time. So if we take 729 times a third, we end up with 729 and then negative 243 is our second term. becomes positive 81, and then negative 27, and then positive 9, and then negative 3, and then positive 1, etc. Now, I've walked my way all the way out to my R value, which I did on purpose here, so that I could show you one way to do this without going back into the formula. Because in this case, when you're missing n, going back into the formula is sometimes harder than just walking out your values. Now, that's not always true. Most of the time I would go back into the formula, and I will still go back into the formula, but for those of you who don't feel like you're going to be able to go back into the formula and be successful, this is a viable way to do this. I'm going to go back into my sequence formula though, and I'm going to talk about how to get my n value back out of that sequence. So in my case, I'm going to come up here and say an is negative 3, a1 is 729, r is negative 1/3, and I don't know n, and it's n minus 1 in this case, right? My first move to get back to n is to divide my 729. This is going to be a ridiculously nasty fraction. You're going to want it as a fraction and not a decimal. If you have it as a decimal, that is going to cause you significant issues. So this turns into negative 1 over 243. Equals negative 1 over 3 to the n minus 1. Now, just like I walked out my sequence over here, and I really only needed to walk out to negative 3, right, because that was the end. I need to walk this up to that. When I have fractions and I'm walking them up, I just walk up the denominator. So in this case, I'm going to say 3 to what power is 243? So I just need to multiply it up. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is 243. And if you don't know that, you can use your calculator. But 3 to the fifth is 243. Now, up here I have n minus 1. N minus 1 is 5. So n is actually 6. And there's the little caveat, right, in that piece up there. So when I've walked it out and I found to the fifth power, that's not my n. N minus 1 is my power, so it goes up to 6. So n is 6, and I found that from down here in my sequence formula. Now for those of you who are wondering, that was term 1, term 2, term 3, term 4, term 5, term 6. So it works the same way if you walk it out. And in this case, like I said earlier, even though I would still go back into the formula, it's almost easier to walk it out in this case. Only when you're missing an n value though, do I recommend that. Now we can work our formula. This little guy is going to be a big problem. So we need to make sure to type him exactly the way he sits. However, the bottom I'm going to do independently of the top. So I'm going to do the top, plug it into my calculator exactly the way Mr. P wrote it. On the bottom I have 1 chop chop plus 1/3, which is 1 1/3, or 4/3 if you want to put it in as an improper fraction. Okay? On the top I need to type 729 parenthesis 1 minus parenthesis negative 1/3 parenthesis to the power of 6 close parenthesis, enter. Now that entire top turns into 728. Now I can divide by the bottom, divided by 4/3, or 1 1/3, and I get a series total of 546. Do the entire top and the entire bottom independently of each other, and then do the division at the end. Don't try to jam the whole thing in your calculator at once, because there's too many opportunities for you to make small mistakes with putting in a parenthesis in the wrong place, or forgetting to put in a parenthesis, or things like that. Now, this extra set of parentheses in here is only necessary if the number is negative, if r is negative. However, I recommend you use it every time, just so you don't forget. I would always put this extra set of parentheses right here on the top. You don't need it on the bottom necessarily, but on the top I would always sneak in that extra set of parentheses. Alright, I want to take a look at this example 2 here. My second example is a sigma notation example. I'm going to plug in the numbers 1 to 5 to my formula. 1, 2, 3, 4, 5. Remembering that only the red numbers are the ones I'm going to care about here, the actual answers. 1, 2, 3, 4, 5 is my n values, that's what I'm plugging in. The actual sequence are going to be coming off of my red values. Now, I plug in 1, I have 3 to the 0, anything to the 0 is 1, times 4 is 4. I plug in 2, I have 3 to the first, 3 times 4 is 12. I plug in 3, 3 minus 1 is 2, 3 squared is 9, 9 times 4 is 36. So my pattern here is times 3 each time, but my starting value was 1. And that's the key to all of this, that we see that pattern. This number out here will always be a 1. This number in here will always be r. So that gives you two options on how to deal with these. You can continue to write out the sequence, which, you know, I might do. 36 times 3 would be, let's see, 90, 108. I'm going to make sure. 36 times 3, yep, and then 108 times 3 is 324. Then you could simply just add up those numbers in the bottom. You'd have 4 plus 12 plus 36 plus 108 plus 324, and I get my series of 484. However, without working out any of this, because of the way I've read my sigma notation, I can go straight into the formula as well. So I'm going to, over on the side here, talk about how to set up the formula for this. A1 is 4. So I have Sn equals A1, 4 times 1 minus r. R in this case is 3 to the nth power over 1 minus 3. Now, I do know n. The trouble is I have to be careful with my counting. In this case, n is fine. 1, 2, 3, 4, 5, it's 5. I'm good to go. If they start you somewhere other than 1 though, make sure you count it up. If they start you like 4 and you go to 7, it's 4, 5, 6, 7. That will be 4. Do not subtract. 5 minus 1 is 4. That's not n. Okay? N is all of the values in a row, 1, 2, 3, 4, 5, which gives me 5. 3 to the 5th. So, I'm going to type in the whole top again. 4, parenthesis, 1, minus, parenthesis, 3, parenthesis, to the power of 5, close parenthesis. And that is negative 968. On the bottom, I have 1 minus 3, which is negative 2. Now I can do that division, divide by negative 2, and I get 484 is the exact same thing I got before, doing it the other way. So hopefully that went well. Now I'm going to work on a couple of homework problems with you and then let you get to work. The homework is on page 674 if you didn't notice that before and weren't following along already. I'm going to start with problem 18. That is not where the homework starts. I know it bothers you when I start in the middle of an assignment. And then I'm going to do problem 24. Problem 18 is A1 equals 4, R equals 0.5, and N is 8. Problem 24 gives us A1 is 3, A8 is 384, and R is 2. Alright, so let's go through our formula here. S sub n equals A1, 4, parenthesis, 1 minus, parenthesis, 0.5, parenthesis, to the 8, over 1 minus 0.5. Again, I will do the whole top independently of the bottom. On the bottom I have 1 minus 1 half, which is 1 half. On the top I have 4, parenthesis, 1 minus, parenthesis, 0.5, parenthesis, to the 8th power, parenthesis, 3.984375. I'll switch it into a fraction in a second. Then I'm going to divide by a half. Switch it over, and I end up with 7 and 31 30-seconds. Good. Just wanted to make sure. Alright, some of these answers are going to be funky. That's just how life is. Alright, now we're going to go down to this one. You times by half each time. They get small. It'd be 4 and then 2 and then 1, but then they go half, a fourth, an eighth, a 16th, a 32nd. So obviously we end up with 30 seconds at the end. Alright, let's take a look at number 24. S sub n equals A1, 3 times 1 minus R2 to the nth power over 1 minus R. Now this one doesn't look like they gave me n, but they did. They just gave it to me in a sneaky way. N is actually 8. An is completely useless here. But this little 8 down here gives me everything I needed. So if they do that to you, if they give you like A6 or A8 or A10, that's your endpoint. So go ahead and put it in as n. Now I can work this out independently, top and bottom. The bottom is -1. On the top I have 3, parenthesis, 1 minus, parenthesis, 2, parenthesis, to the 8th power, close parenthesis, negative 765. When I divide that by -1, I end up with 765. So your homework for today is on page 674, 17 through 37. Hopefully that all goes smoothly. There are a lot of different components in there, but nothing new or shocking that should be popping up. If you have problems with this one, just like if you had problems with any of the prior lessons, feel free to ask when I get back. Hopefully the week went well. Remember that none of these homework assignments are going on this quarter, so there's no panic to have them done by the end of the day Friday. They're all going on 4th quarter. We started 4th quarter with chapter 11. So there's no reason to be hyper worried about this. We have time, we'll get it done, and we have several more lessons before the chapter's over. So if things aren't going well, we'll get it back on track. But I think for most of you, things should go well.